Finding equations of exponential functions. One way to find an equation of an exponential function of the form y equals ab to the x is to use the base multiplier property. If the value of the independent variable increases by 1, then the value of the dependent variable is multiplied by the base b. In this example, use the base multiplier property to find an equation of an exponential function whose graph contains the points listed in the table. X is 0, f of x is 2. X is 1, f of x is 6. X is 2, f of x is 18. X is 3, f of x is 54. X is 4, f of x is 162. For our function, we want to use f of x equals a b to the x power. When x is 0, f of x is 2. So what that means is if I have f of 0, I would have a times b to the 0 power. B to the 0 power is 1, which is just a. Or if you remember, a is the y-intercept. So we know a equals 2. To find b, we want to figure out the change from when x equals 0 to when x equals 1. To get from 2 to 6, I would need to multiply by 3. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. So that means our b is equal to 3. That means our equation, f of x, will equal 2 times 3 to the x power. You can always check your equation by substituting the values of x in for x and see if our result matches our table. Solving equations of the form a b to the n equals k for b. To solve an equation in the form b to the n equals k for b, 1. If n is odd, the real number solution is k to the 1/nth power. 2. If n is even and k is greater than or equal to 0, the real number solutions are plus or minus k to the 1/nth power. 3. If n is even and k is less than 0, there is no real number solution. In this example, find the real number solutions of b squared equals 9. Our first step is to get b. Since I have b squared equals 9, the only way I can find b is by taking b to the 1/2 power. 2 times 1/2 is 1, which would just give us b. If we do that to the left side, we must do that to the right side. So b equals, my denominator is even. That means I'm going to have plus or minus, since my 9 is positive, and the square root of 9 is 3. So my values for b are positive and negative 3. Find all real number solutions. In this example, we have b to the third equals 27. For this problem, we want to take our b to the third to the 1/3 power so that we have b to the first. What we do to one side, we do to the other. b equals, the cube root of 27 is 3. Since the denominator 3 is odd, I use the sign of the number in my parentheses. 27 is positive, so 3 is positive. So b equals 3. In this example, find all real number solutions of 3b to the fourth equals 48. Before we can get rid of the exponent 4, we have to deal with the 3 in front of the b. Since it's multiplication, I can divide both sides by 3. B to the fourth power equals 16. Now I'm ready to take both sides to the 1/4 power to get rid of the 4. So that gives me b equals, the fourth root of 16 is 2. Since 1/4 has a denominator of 4, 4 is even. I want to use plus or minus for my answer. So b equals plus or minus 2, or b equals a positive 2 or a negative 2. Find all real number solutions. Round all results to the second decimal place. 2.7 b to the fourth minus 5.3 equals 351.9. First thing we need to do is isolate b to the fourth. Subtracting 5.3 from both sides, I have 2.7 b to the fourth equals 357.2. Dividing both sides by 2.7, b to the fourth equals 132.3. Now I want to get rid of the fourth power. I can do that by taking it to the 1/4 power. I need to do that to both sides. To find the fourth root of 132.3, power, parenthesis, 1 divided by 4, close parenthesis, enter. So that gives us 3.39148547. Rounding to the second decimal place, we have 3.39. So b equals 3.39. Since my 4 is even, plus or minus. Final answer, b equals plus or minus 3.39. Find all real number solutions. Round all results to the second decimal place. In this example, we have b to the seventh divided by b squared equals 86 divided by 4. Our first step is to simplify this as much as possible. B to the seventh divided by b to the second is b to the fifth. 86 divided by 4, I can reduce that to 43 divided by 2. Now I want to take the fifth root of both sides. Then we calculate 43 over 2 to the 1/5 power. So we have parentheses, 43 divided by 2, close parenthesis, to the power of, parenthesis, 1 divided by 5, close parenthesis, enter. My answer is 1.847088447. Rounding to the second decimal place, we'll have 1.85. B equals 1.85. Since the 5 in my 1/5 is odd, I use the same sign as in the parentheses, so my final answer is B equals 1.85. Using 2 points to find equations of exponential functions. We can find an equation of an exponential function by using the base multiplier property or by using 2 points. In this example, find an approximate equation y equals ab to the x of the exponential curve that contains the following points. Round the value to 2 decimal places. 0, 3, and 470. Because 0, 3 is the y-intercept, we know that a equals 3. To find b, we substitute everything we know into y equals ab to the x power. My y is 70, equals my a is 3, b I don't know, my x is 4. Dividing both sides by 3, I have 70 divided by 3 equals b to the fourth power. To get rid of the fourth power, we want to take each side to the 1/4 power. So now we need to calculate b. Parenthesis 70 divided by 3, close parenthesis, to the 1/4 power. Enter. We get 2.197830502. So rounding to 2 decimal places, that gives me 2.20. So now that we know a and b, we can write our equation. Y equals 3 parenthesis 2.20 to the x power. In this example, find an approximate equation y equals ab to the x of the exponential curve that contains the following points. Round the value to 2 decimal places, 2, 5 and 5, 63. So for this example, we're not as lucky as we were with the previous example. We don't know what a equals. So this is going to be a little more complicated. Using the point 2 and 5, 5 equals a, b to the second power. For the ordered pair 5, 63, 63 equals a, b to the fifth. What we can do here is use proportions to help us solve this. So what I want to do is take 63 and divide it by 5 and set that equal to a, b to the fifth, and divide that by a, b to the second. When setting up a proportion like this, it's going to be easier for us to work if the larger exponent of b is in the numerator. That's why I used 63 on top and ab to the fifth on top. Simplifying, I'm going to keep my 63 over 5. Our answers are more accurate if it's a fraction. The a's cancel, leaving me with b to the third power. So now I can get rid of my cube by taking both sides to the 1/3 power. Calculating, I have parenthesis 63 divided by 5, close parenthesis, to the exponent of parenthesis 1 divided by 3, close parenthesis. I have 2.326966771. Rounding to 2 decimal places, that's 2.33. So 2.33 equals b. Now that I have b, I can find my a. I'm going to use 5 equals a, b squared. So 5 equals a times 2.33 to the second power. Divide both sides. I have 5 over 2.33 to the second power equals a. The reason I did this was so I could type it in my calculator all at once. 5 divided by 2.33 squared equals 0.920996887. So a equals 0.92. Now that we have a and b, we can write the equation. Y equals 0.92 times 2.33 to the x power. Finding equations of exponential functions. We can find the equation from a table of an exponential function if the value of the independent variable increases by 1, the value of our independent variable is multiplied by the base b, starting with 0 and the output for 0, which is a. We can then look at all of our outputs to see the change between each. Solving equations in the form of a b to the n equals k for b, our first step is to divide both sides by a, then take each side to the 1 over n power. If I have b squared, I use 1/2. If I have b to the third, I use 1/3. Using 2 points to find equations of exponential functions. If I have the y-intercept, then I already know a. I can substitute all my given information into y equals ab to the x and solve for b. If I have 2 points and neither of them is the y-intercept, I can substitute in for x and y, create two proportions, find b, then use that value to find a.